Hi, so in this screencast I'm going to be showing you how to adapt the zip.train dataset for use with our keras. So in the last screencast we saw that using the mnist dataset with a model fit function here from keras requires that the x-train has to be in a very specific kind of format. Right, so x-train here looks like a four-dimensional array where the first dimension corresponds to the number of observations, the second is the number of pixels high, the third is the number of pixels wide, and the last one is the number of channels. Here it's only one channel because it's a grayscale image. So when we look at the zip.train data set up here, let's take a look again. Here, if we look at the zip.train data set, it's not quite in the same format. So it's, when we read it as a data table, it's it's just one row per observation. So we want to reformat that into an array. So how are we going to do that? So I think probably the easiest way to do that is to just use a call to the array function. So when we use array, we have to, let's take a look at a simple example. Say that we want to make an array with the numbers between 1 and let's say let's first specify the array size. So say that there's two observations with how about three pixels high, 3 pixels wide, and one channel, right? So if we want an array that looks like that, let's say 1 to some a size. Let's take a look at what that array looks like. So this is what our printout looks like when we have an array. So the first so here what the printout looks like is here we have this is what the indices, this is what the entries look like for observation 1, right? So for the first dimension here, this is 1. Sorry, this is super confusing, right? So actually, so the comma 1 means, okay, well, this is what all the observations look like when the third and the fourth indices are equal to 1. And here, this is what it looks like when the first index is equal to 1 or 2. And here are the values of what it looks like when the second index is equal to 1, 2, or 3. Okay? So what we see is that when we use the array function like this, R is filling up the first the first kind of, it's holding the last index constant and then filling up a bunch of entries according by every column, right? So it goes down the columns, 1, 2 in the first column, 3, 4 in the second column, 5, 6 in the third column, and finally gets all of the guys. So what would we have to do first of all to visualize this data better? Well, first of all, we may want to Let's call that A, and let's do stir A, see what that looks like. So yeah, indeed this is an array with 2 items in the first dimension, 3 items in the second and third dimension, and 1 item in the last dimension. Right, and when we look at the, the printout here, it says 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And so that's corresponding to all these numbers that we were looking at here. So yeah, so I mean, essentially, I mean, what we can think about are doing is, it's taking as input this vector of numbers between 1 and here 16. Is that right? 1 and 9. Is that right? Yeah, so sorry, this is not right. It should be prod A size. Let's try that. Right, and then A looks like this. Yeah, so it should be going up to 18. So yeah, because the point was to kind of show like how R fills in these numbers. So yeah, I mean, it's trying to fill in this, the matrix of values. Yeah, so I guess yeah, I guess like one way to think about doing this, we can think about just doing, let's get let's get the zip train. Let's just get 2 of the zip train observations. The first 2. Just these first 2 columns. And so what are we going to do with these guys? Let's try to reshape them into the array of the required size. Actually, even better, let's just try to do it with 1 of the guys to see if that works, right? So here, first of all, what we're going to have to do is we're going to have to ignore the first column. So let's just do that right away with a -1. But then we just get those 256 remaining columns. Let's convert it to a matrix, as numeric. Will that work? Now let's do unlist to get them as. Ooh, that's not gonna work because it's way too many. So how about just that? Okay, right. So that gives us a numeric vector, and if we want to just convert that one numeric vector to a matrix, I mean, it's relatively easy. We can do matrix, 16, 16. Right, call that n, and we get a 16 by 16 matrix, right? And if we want to do an array, it's basically the same thing. Just replace this. So how about zip array 1? Let's call that. So zip array 1 is actually, basically the same thing. And so how do we get that into now the question is, how do we do that for several guys at the same time? Well, it would be nice if we could just do this, where we have, let's say, zip train 1 to 2 -1. So it's the first 2 observations. Minus 1 means without the label column. And it would be nice if we could just pass that to array and get that the right size. So how about if we say 16, 16, 2, 16, 16, 1? Will that give us the right Well, it'll give us an array of the right size, I think. Well, yeah, not exactly. So here, here again we need this unlist. Convert it to a vector. Then we pass it to array. Then we do get something which is the right size. But is it the right data? Let's see. Let's call it zip array 12. So now zip array 12, if we just look at, say, the first, sorry, that's not right. We need actually 3 commas now because it's a 4-dimensional array, right? So here, if we just look at the first thing, so this is a 16 by 16 matrix. Is this equal to zip array 1? If we're lucky, it is. And actually, indeed it is, right? So all of these are equal. So actually, we can construct the whole thing by just using this same expression here, but replacing, let's see, replacing your zip array, let's call that zip array, and there we can just use in row zip train here, in row zip train, and so what that's going to do is that's going to give us an array. So let's look at that zip array now using the str function to show us the structure of that R object. So now it's a 4-dimensional array in R. So mathematical object is a 4-dimensional tensor, and the idea is that here these 7,291 elements in the first dimension correspond to different observations. The second and third dimensions correspond to the different numbers of rows and columns, and then that last dimension is if we had different channels, but here we've only 3 cylinders, so we only have 1 channel. And so again, if we take a look at the zip array, just taking a look at the first observation, and say if we only look at the first 5 rows and columns, here we need another column, and need another comma there. That's not super useful because they're mostly negative ones, so how about we go between 5 and 9 instead. So I'm just looking at an arbitrary element, some arbitrary elements of this matrix. So I want to compare this to what we had before, just to convince that we're actually getting the same information. Zip array 1, this is when we just constructed it manually, just on the first one without doing this. So let's see, we have to do like this, and so if we did our job right, all of these values should be the same, and indeed you can see they all match up, and that jives. That's consistent with the equals comparison that we did earlier. So in conclusion, you can just take this zip train data set as read from data table in R, and just with a couple of simple calls to the unlist function and the array function, now you have this zip array object, which you can just pass directly to the fit function in our keras. The other thing that you might want to do is you might want to create a zip label array. So here, maybe to be more specific, you could call this zip x array, and then zip y array, and then this would be, actually you can just take the vector of observations from the first column of zip train. So zip train, I think it was zip train v1, right? If you do that, then you have zip y array, which is just this this numeric vector of labels, and then what you would do to pass it off for training is the same thing that we did with the mnist data set. We use this two-categorical function from keras, and if we do if we use that code, let's just copy that, zip y array. Here, let's call it zip y mat, because it's going to become a matrix of indicators as an output. So I think this is keras, two categorical, and so instead of doing mnist data here, let's use the zip y array that we just created, or we don't even need to create that intermediate variable there. We could just use zip.train v1 there instead. And then num classes, that's it's again going to be 10. If you wanna convince yourself that's actually true for this data set as well, you can do table zip train v1, and that'll be, let's call that zip class tab. And zip class tab, this is, if you take the length of that guy, that's telling you the number of counts of all of the labels in that data set. The length is 10, and you can use that in that construction there. If you do that, then you'll get this zip y mat, and that thing is something that you can directly pass to the keras model fit function. So yeah, so thanks for listening to this tutorial. We've gone over how to take the zip.train dataset from a CSV file to a data table in R to an array, and an array of inputs or X values and a matrix of Y values that we can use for the keras fit function. Thanks for listening.